Hey everyone, and welcome to the day 2 of the Star Wars unit video notes, also known as the Similar Triangles unit. Today we're going to be talking about similar polygons. Go ahead and try the warm-up on your own. Once you have tried it, you may resume the video and check your answers. For solving the proportion, the first thing we want to do is cross multiply. 3 times 7 is 21, 2 times x is 2x, and divide by 2 to get 21 over 2, or 10 and a half. For number 2, we are once again going to cross multiply. This time don't forget to put your terms in parentheses, then distribute your 2 and your 4. Subtract 2x on either side, subtract 4 from either side, and divide by 2 to get x is 4. For number 3, the measures of the angles in a triangle are the extended ratio 2 to 15 to 19. Find the measure of each angle. I'm going to multiply all these by x, then add them up and set them equal to 180. So we've got 2x plus 15x plus 19x equals 180. Means 36x equals 180. And divide by 36 to get x equals 5. Now they're asking for the measure of each angle, so I still have to plug it back in. 2 times 5 is 10 degrees, 15 times 5 is 75 degrees, and 19 times 5 is 95 degrees. Next, the perimeter of a rectangle is 84 feet. The ratio of the width to the length is 2 to 5. Find the length and the width. We know our formula for perimeter is 2 times the length plus 2 times the width. Next, we're going to plug in 5x and 2x for our length and our width. Multiply and solve for x. Once you've solved for x, make sure that you then plug it back in. 2 times 6 is 12 feet, 5 times 6 is 30 feet. Lastly, find the geometric mean of 1 and 100. I'm going to multiply 1 and 100, put them under the square root, and then take the square root, and we get 10. If you have any questions on the warm-up, be sure to ask your teacher or write it on a sticky note. Next, the lesson for today is on similar polygons. Here's a definition for similar polygons. There are polygons that have corresponding angles congruent, and the corresponding sides are proportional. So that's why we practiced so much proportions last class. The way you write a similarity statement is with this little tilde in between. So this would be read A, B, C, D is similar to E, F, G, H. For example number 1, in this triangle, they're telling me that triangle RST is similar to triangle XYZ. So I know all the angles are congruent and all the sides are proportional. They want me to list the pairs of congruent angles. We're going to do this the exact same way we did it for congruent triangles. We're going to look at what is in corresponding places. So angle T is my last letter here, so I know it's going to be congruent to angle Z. Next we have angle S, which is my middle letter. It's going to be congruent to angle Y. And angle R, my first, is going to be congruent to my first angle X. Check that the ratios of the corresponding side lengths are equal. So once again, what this means is you have to look to your similarity statement to figure out which sides are corresponding. Here I have side RS. RS is 20, and that is corresponding to side XY, which is 12. So when I create a ratio of these two sides, I'm going to put 20 on top and 12 on bottom, my large triangle on top and my small on bottom. Then we're going to simplify it. Remember, you always want to simplify, so that simplifies to 10 divided by 6, which simplifies to 5 over 3. You can put the small on top of the large. You just have to make sure you do the same order for all three. So since I put my big triangle on top, my little triangle on bottom, that's what I'm going to do for my other sides. Next, I'll look at side ST. Side ST is 30, so the last two letters, and my corresponding side is side YZ, 18. So I'm going to put my large on top of my small, 30 divided by 18, which also simplifies to 5 divided by 3. Last, we have side RT, which corresponds to side XZ. So I'm going to take my large on top of my small, 25 divided by 15, and that gives me 5 divided by 3. Since all of these ratios are the same, I can say the sides are proportional. Next, they want to write the ratios of the corresponding side lengths in a statement of proportionality. You may want to put a star next to that. Whenever you see this, that means that you're going to write your sides like a proportion. So here we're going to say RT is proportional 2xz. And once again, you can figure that out by looking at your similarity statement. RT and XZ are in the same position. Next we have side TS, which is in the same position as side ZY, so they are proportional. And lastly, side RS and side XY. Our next definition is a scale factor. A scale factor is the ratio of the lengths of the two corresponding sides. So in other words, 5/3, the ratios we just found in our last example, that was the scale factor for those two polygons. Next, we want to determine whether the polygons are similar. Remember, that means all angles must be congruent. So I look here and I see I've got 1 pair of congruent angles, 2 pairs, 3 pairs, and 4 pairs. So all my angles are congruent. Then we have to check and see if all their sides are proportional. That's the next step. So let's look for some corresponding sides. I see that my first two sides that I'm going to look at are side ZY, and I see that that is proportional to, or corresponding to side FG, ZY and FG. Once again, I'm going to put my large shape on top and my small shape on bottom. So that gives me 25/20, which simplifies to 5/4. Next, I'm going to look at side WX, which is corresponding to side JH. So I'm going to take my large side, put on top of my small. So we've got 15/12, which once again simplifies to 5/4. Looking good so far. Next, I'm going to look at side YX, which is 30, and side GH, which is 24. 30 divided by 24 simplifies to 5/4. And then my last two sides, we've got 20/16, which again simplifies to 5/4. So since all of my sides have the same ratio, that means that this shape is similar, these shapes are similar, and the scale factor is 5/4, the ratio we just found. In the diagram, triangle DEF is similar to triangle MNP. Find the value of x. We're going to have to set up a proportion to solve this problem. So the first ratio I'm going to set up, you have to look for two corresponding sides that both have numbers. I see side DE and MN both have numbers, and they are in corresponding places, so I can set up a ratio using those two sides. I'm going to put my small triangle on top of my large, because we can do it in either order. So that gives me 9/12, which is this ratio here. Now for my second ratio, I know I need to use x, because x is what I'm searching for. X is on side EF. The corresponding side to EF is side NP. Since I put my small triangle on top first, I must put my small triangle on top again, so it equals x/20. Now we're going to cross multiply. Get 12x equals 180. Divide by 12, and that leaves me with x equals 15. For the next one, we're talking about the perimeters of similar polygons. Remember, perimeters are when you add up all the side lengths of a shape. What they're saying here, that is, if two shapes are similar, then we know that adding up all their sides, or finding their perimeter, is the same as finding each ratio of sides separately and then adding them together. So in other words, the ratio of perimeters is going to be the exact same as the scale factor. So once you find the scale factor, you know the ratio of the perimeters. In this diagram, they're telling me that ABCDE is similar to FGHJK. Find the scale factor. Since I know that they're all similar already, then I don't have to check every single side. I can just check one. The side I have to use here is side AB, because that's the only one with a number. And I see that AB is in corresponding places with side FG. I'm going to put my large on top of my small. So I'm going to set up a ratio here, 15/10, which simplifies to 3/2. And that is going to be my scale factor. Now they want me to find the value of x. We're going to use our scale factor, 3/2, to set up a proportion. We know we have to use x because that's what we're looking for, so we're going to set it equal to we're actually going to put x in the denominator since that's in my small shape, and I put my small shape on bottom here. So x will be in our denominator, and AE is in corresponding places with side FK. So we're going to have 18 over x set equal to 3 over 2. Then we're going to cross multiply, and we get that 3x equals 36, and we're going to divide by 3 to get that x equals 12. Now they want me to find the perimeter of shape ABCDE. Remember that we said that this ratio of the perimeters is the same as the ratio of the sides, or the scale factor. So we know we're still going to be using 3 over 2. And we're going to set it equal to the ratio of the perimeters. So first we have to find the perimeter of my large shape, because I have all the sides of this. So we add up 15 plus 9 plus 12 plus 18 plus 5 to get that perimeter, which is 69. We do not know the perimeter of my smaller shape, so we're going to leave that as x. We said we're going to use the scale factor, so we're going to use 3 divided by 2. We're going to set it equal to 69 over x, because 69 was the perimeter of my large shape, and x is the perimeter of my small shape. Now we're going to cross multiply and get 3x equals 138, and divide by 3 to get x equals 46, or the perimeter of ABCDE is 46. Next, in this picture, they are telling me that triangle TPR is similar to triangle XPZ. Find the length of side PS. In similar triangles, all aspects or parts of a triangle are proportional. This includes the altitude. Now, if you haven't heard the word altitude before, here's the definition. It's the perpendicular segment, which means segment that intersects to form a right angle, from one vertex to the opposite side. It's also called the height of a triangle. We're looking for x, or we're looking for PS, which I can label with an x, and we're going to have to set up a proportion in order to solve this. So first I'm going to look for the side of my triangle. The side that I know of PTR is TR, and it's actually 12, not 6, so if you add these two pieces together. The corresponding side in my second triangle is side XZ. So I'm going to start with 12 divided by 16. Now to set up my second ratio, I'm going to look at the altitudes. The altitude of my small triangle is x, since I put my small triangle on top over here. I have to put my small triangle on top over here. And the altitude of my large triangle is 20. Now we're going to cross multiply 20 times 12 and 16 times x, and divide by 16 to get that x is 15. Now, finally, the last problem. A town is building a new swimming pool. An Olympic pool is rectangular with a length of 50 meters and a width of 25 meters. The new pool will be similar in shape, but only 40 meters long. So right there, they just gave you the length of the new pool. Find the scale factor of the new pool to the Olympic pool. The only length they gave me of the new pool is the 40 meters, so I know I'll have to compare the length of my new pool to the length of the Olympic pool. I'm going to use that to make my scale factor. I'm putting the new pool on top and the Olympic pool on bottom. So we've got 40 divided by 50, which equals 4 over 5. Now I want to find the perimeter of the Olympic pool and the new pool. Remember that the ratio of the perimeters is the same as the ratio of the sides, so we'll be using this 4 over 5 to help me with part B. First I have to find the perimeter of the Olympic pool. Remember, that's 2 times the length plus 2 times the width. I know the length and the width, so I can just plug those in, and we get that the perimeter of my Olympic pool is 150 meters. Now we're going to set up a proportion. 4 over 5, remember, was my scale factor. So I'm going to set that equal to the ratio of the perimeters. We just found the perimeter of my Olympic-sized pool, so that goes on the bottom, is 150, and we don't know the perimeter of my new pool, so I label that with an x. Now we're going to cross multiply and solve. That leaves me with 5x equals 600, and x equals 120 meters, so my perimeter will be 120 meters. We're also in class going to discuss the areas. I'll be looking on your post-it note sheet to see if you write, what about the areas? Everyone have a great night. Hope you have a fantastic winter break, and we will see you when you return.